The objective of our proposed system is to measure the distance between a vehicle and its surroundings in order to successfully navigate an obstacle course. Basically, what we're doing is mounting a proximity sensor on a small vehicle and then putting it in a confined space with obstacles scattered around. The vehicle will then navigate its way around these obstacles in order to reach its target.
The sensors we'll be using for this project will be ultrasonic sensors. Particularly, the sensor we are planning to use is a HC-SR04 sensor. It will be used to detect the distance between the robot and any obstacles, and send information to LabVIEW in order to change the direction of the robot to avoid obstructions in its pathway. How this sensor works is by sending out a signal at a specific frequency and measuring the time it takes for that signal to echo back. The HC-SR04 does this through the use of two ultrasonic transducers. The first transducer sends out the signal, and the second transducer is used to detect the signal that is reflected off a surface. From this, we can formulate an equation to determine the distance by using the time recorded by the sensors and the speed of sound. One thing to note is that the accuracy of ultrasonic sensors can be affected by the temperature of the air, since the speed of sound varies with temperature.
The building blocks of our system are as follows. First, we have the sensing stage, where an ultrasonic sensor is used to detect change in distance between two objects. Then we have the transducer stage, where a piezoelectric transducer converts incoming sound pressure into a measurable voltage through mechanical motion. Then we have the signal conditioning stage, where integrated circuits on the device compare the generated voltage from the transducer to the output signal of the vibration, which filters out unwanted noise and provides the ability to accurately measure time intervals. Then we have the data acquisition stage. We'll be using a National Instruments USB 6008 DAC to record the output signal of the sensor and use it for further signal processing. This platform provides a versatile base for data acquisition and instrument control. And lastly, we have calibration, where the sound pressure is converted into a distance measurement through the use of a standard speed, usually the speed of sound, a known output signal waveform, and an accurate time measurement system. These 5 building blocks are inherently linked, as they rely on each other sequentially. For example, the signal conditioning phase relies entirely on the proper functioning of the piezoelectric transducer. Similarly, the data acquisition phase relies on the fact that the signal conditioning phase operates properly.
I would now like to describe some of the potential applications of our proposed measurement system. One application that comes to mind right away is the modification of robot vacuums. Many customer reviews state that these automated vacuums tend to bounce around when encountering obstacles. Our proposed system could allow for proper navigation through these obstacles and clean those tricky areas. Being able to maneuver around any interferences would reduce collisions and thereby increase efficiency. Children's toys is another large area that could be improved with application of our proposed system. One particular example would be implanting this technology within pre-existing child-sized vehicles. This could significantly reduce the risk of injury and make for a more enjoyable ride. On a larger and more significant scale, this would be a great method to help the mobility impaired and elderly with tasks that they can no longer do for themselves. With our aging population, a technology that would allow for more automated services, both inside and outside the home, would be a welcome innovation. One example of this could be an autonomous lawnmower that would be able to navigate the yard. A further application would be to implement this technology within drones. Drones are becoming increasingly popular as a pastime pleasure for many individuals, and more recently being used by companies to ship out products. Implementing this system within these devices would add a level of safety and assurance. Safety of air traffic at a smaller scale, such as drones, is a field that has yet to be tapped into and one that will be increasingly important over the coming years.